G'day guys and welcome back to my channel. I've just got a couple of things to say quickly first before I start. Like I said in the last video, maybe last two, I can't remember, I've got a lot of stuff going on this week. Tomorrow I'll be out most of the day. I might get a video done when I get back, but put it this way, today I'm going to try and bang out a few videos and just get a few things done in here. And then after tomorrow, I might be a little bit busy the next day. But after that, basically things will be going back to normal. I'll have the time on the days I'm not at work to put 2-3 videos out, a couple of shorts, whatever. You know, it won't be this one video a day or one video every 2 days thing. Again, my content will be going back to normal. The other thing I wanted to say is in the last video, I had problems with my camera. Well, not the camera so much, but the video merging software that I'm using on my phone. Yes, I'm still using my phone to stitch the videos together. What I found is because it's, video processing takes a lot of power, performance, memory, GPU, CPU, that's what I'm talking about. If you're wondering, I guess that takes physical power too, but you get what I'm saying, right? The phone isn't exactly a powerhouse. It's not like my desktops. Yes, I am going to get video editing software on my desktops, and I'm going to get cameras and all that stuff, and I'll be doing things differently soon. But this for now is what we're doing. I just wanted to say what the problem turned out to be is the video processing software, because it takes so much load, like CPU intensive, whatever. I tried shooting other videos whilst merging. Say I'd shoot 2 videos. I'd open up the merge software and have it merging those 2 videos, and I'd open up my camera and start recording another video. Well, once I got past 2 iterations of this, the software just screwed up all my merges. When I played that video back, there were segments in the wrong order, which wasn't me, that was the software. Like, I record my videos and it just gets saved to the phone, right? Next one, you open up the folder, they're all in order. And I just drag and drop each one. The last 3 digits are different on each file. Like, you can't put it in the wrong order. So it rearranged a couple of my clips, made some of the video blotchy and all pixelated, and it messed up the sound. I got rid of the sound for some of it. So because I was designing a circuit from scratch, I went through a few different iterations to get to this, and well, I didn't really get to explain everything to you guys properly because, like I said, the segments are in the wrong order. It was just a mess. Anyway, so what I'm going to do first, if this works, because these wires, I'll just show you guys something. So I got breadboard wire here from when I was a kid, and I got the stuff that you buy now at JCar, and you probably already see the difference. Let me get a piece of already stripped wire that I've got. You see the thickness difference? Probably not, eh? But I'm telling you, this blue wire is a lot thicker than this. Both the insulation and the wire. And these new breadboards aren't like... See, I've still got one of these old brass boards, this back one here that's got a few holes burnt in it. That's brass strips in there. I don't have any connectivity issues when I use that breadboard. And I mean, like, you can probably tell there's an op amp there that was sensing a current shunt, another one that was sensing a leakage current shunt, and then deducting that off another op amp from that answer and outputting to another op amp that compares that against the reference. It's a constant current circuit. The reference isn't there, and the third op amp's not there at the moment. But my point is, I know that bottom board, out of those 2 boards, gave me trouble. The top one works beautifully. This is that the strips in it if you look at them, they're silver. They're like chrome, or I don't know what they're made out of. They're steel because they're magnetic, and then they're plated in some sort of chrome or whatever. They're shit. You know, you just wiggle stuff around. See that? It's very hard to get a circuit to work properly. With this crap. So what I'm going to do, let's see if that's working right now. Let me just get out my power supply, because what I want to do first, I mean, yeah, no, that's dodgy as. Let me go and clean up. I'm going to spray some stuff in the holes, slide things in and out, and rip all these wires out and go and replace them with the thick old school wire. And then I'll come back and I'll show you how this works. I mean, let me just have a quick look. Let's see how bad it actually is, because our input voltage is there. What's on our VREF high is there. I need to grab a wire. Should do the trick. Yeah, our VREF high and our VREF low are stable. What do we reference to? Ground. Good. What is our... Oh, that's our negative. So yeah, we've got volt drop across the negative rail. That's what's going on here. That's all over the shop. I don't understand. Really that bad? Yeah, I know I'm wasting shit. I'm just trying to get this done. I just want to show you guys, you know, I don't want to sit here screwing around with crap. It's smaller. Blimey. Alright. Let me just go move the threshold. And my meter. So I want to show you guys the input voltage. So when it goes above 3.2, the LED goes off. When it goes to 3.2, 3.1, 3.9, sorry, 2.9, you see the LED still on. But as soon as we go down to 2.8, or just below 2.9, the LED goes off. So there you go. I didn't have to redo all the wires. It was just that one wire that's causing me the most trouble. It's just because it's a very sensitive circuit. Any amount of offset on those comparators is going to completely fuck it up. Yeah, I've got to get out the habit of swearing, don't I? Sorry. Anyway, so well, it looks like I can show you guys the mode of operation, so that's good. Okay, so as you saw, we have our, I think this was the VREF high and this was the VREF low. Basically, one side of the comparator is looking at VREF low and comparing the input voltage against VREF low. If it meets that requirement, its output swings to ground. It's an open collector output. The other side's looking at opposite VREF high or VREF low and comparing the battery voltage against that. And if it meets that requirement, the output turns on to ground. It's an open collector output. Pulls down to ground. So then we take those two outputs, right? Wait, how do I not have a port resistor on here? Oh, I've just noticed something odd that's boggling my mind. How am I comparing a positive voltage here when I haven't got port resistors on the open collector outputs? Hold on, I've just got to see something. This could actually be a bit dodgy. I might have yeah. Oh, have I done it so when they both pull down to ground? And then I must have set a ground threshold. I can't even remember what I did, guys. Sorry. I could pause the video, but I don't know, I think sometimes it's better to show confusion and working stuff out, because that's how we all learn, right? Yeah. Okay, so it's been compared against nothing. Okay, I'm not happy the way I've done that. I mean, it works, doesn't it? I'm going to have a think about this. Because basically what I've got is I've got the open collector outputs just going straight to two 10K resistors to the positive input. Positive input. And the negative input's looking at a 2 millivolt reference. Yeah, I don't trust that so much. I know the LED is flickering because of that wire, but I'm wondering how much of the instability is the way I've done this. I could solder it all up so that it's not all loose and then see how it performs then, but I think what I'm going to do, I'm going to get a couple of 4.7K resistors. Sorry about my head being in the way, I'm just looking in my resistor box. Or the one that's on the table. I'm just going to pull up these two open collector outputs to VCC, or the boost VCC. Because that is also the rail that is powering the comparators. So that's the rail it's going to have to get pulled up to. Let me get some more oxidized wire. I'm sick of having to fucking cut and re-strip everything. Alright. So they pulled up the positive. I'm going to have to put my voltage back to 3 volts where the LED is on. Just on. Right in the middle of the window. We still got our high and low threshold, so we should just have to adjust this threshold until the LED comes on now. See if this makes the circuit more stable. Actually, I think that is more stable. Let me just go to the power supply. Let me move my meter back to the battery input voltage so you guys can see the thresholds it's kicking over at. I might even get all this in one video this time. Yep, 2.897. Oh, that's perfect. So there you go. It was actually me. My design was terrible. I just wasn't leaving enough headroom basically for the inputs. Now I'm pulling the open collector outputs up to the positive rail. Which, come to think of it, why have I got 4.7K resistors in there? That's to drive an LED. I only need like, geez, maybe 100. Oh, 1 meg should do it. Yeah. No. It's an open collector output, eh? I'm just going to stick a meg on one of them and just see what voltage that pulls it up to. Because remember, I'm trying to keep this like as low current as possible. I think I know something. I've got this gut instinct. I'm having a fucking brain dead moment here. But I just want to see, with a pull up resistor on one of them, what does that pull it up to? Okay, very, very small value. Without the pull up resistor, it's higher. Well, I guess that those 4.7Ks are only on when the LED's on. If I make them 10K, that's the equivalent of 5K. Let's do that. Let's see if we can get it to work with 10Ks there. Because it's only supplying, well, actually, no, that's not true. It's open collector output, so it's pulling down to ground. So whatever current you supply, I guess it's pulling down to ground. Am I having a stupid moment? Or am I right? I think that's right. Well, I'll just leave this recording and let you guys watch me fucking around. I don't edit any of my videos out, but like if I have a really, really, really bad day where I'm walking in and out, I will pause them and like stitch them together. But I'm in a good mood right now. I'm pretty patient. So I think I'm just going to try and shoot this one in one go and just show you guys. Alright, what voltage have we pulled up to now? That's high, that's 230. 3.1 volts. Maybe the collector's not turning, the open collector output isn't turning on very hard. I don't know how much current it's trying to sink to ground. I haven't worked that out yet. I've got to go look in the data sheet. I know this is really stupid of me. And as a lot of you people who build stuff know, once you've been doing this shit for years, you just start winging it like what you see me doing here. You just start playing with shit. You have a feel of what your ballpark values are, right? So you know you're not going to blow the thing up by putting a wrong value component in because you're that good at it. I'm not trying to be cocky, but you're that good at it that you know what your ballpark figures are going to be, right? So you put ballpark figures in and then you can fine tune it from there. You know, obviously you can't start with a 1 ohm resistor and end up with a 1 meg resistor. That's nowhere near the ballpark. But I mean, once you've been doing stuff for a while and you know the region you're going to be in, you can start doing less calculations and just winging it and swapping out values until you get it right. And sometimes, well, most of the time, all these negative rails are dodgy. Really? Who's that? Oh, hey man. I'll be back, guys. Just give me a sec. Alright, I'm going to wrap this up in a minute, but I'm still going to just get this done quickly. My mate's here. Haven't seen this bloke in a while. So, I'm just going to measure these voltages quickly. Oh, wow. Even with a 4.7K? What? Oh, blimey. I've got my multimeter on negative. I'm looking at the wrong rail, guys. That's why. Okay. Fuck. Some of you are probably fucking looking at the board and screaming at me in the comments. Dave. Yes. I need to look at the positive rail. I realise that now. Get in there. Should use something a bit sturdier. I'm not adding a component here. I mean, I might as well stick this across the rails. It won't hurt, but I'm actually adding it so I've got something to clip onto. Alright, 7.71. That's more in the ballpark I was expecting to see. Let's go back to tens and then hundreds, meg. I just want to see how high I can get the resistance for the pull-up resistor, because don't forget these are on the open collector outputs. So when the comparator's output turns on, it's basically a transistor pulling the open collector output down to ground. So you put a pull-up resistor on there so that when it's not pulled down to ground, so when it's off, it's pulled down to ground. When it turns on, it goes open. You know, so if you put a resistor in there to provide some voltage, see, 10k does the trick. I had a feeling. You know what? I'm just going to go straight back to the 1 meg. So I know that gets annoying with my head. I should just grab the resistor box and move back, right? Well, let's just stick one in there first and measure the voltage on it and see if it's even appropriate. 7.84. I'm going to go get a couple of mega ohm resistors because I know there's only one more in that box. One meg. Not 10 meg. 1 meg. I almost grabbed a 10 meg resistor. You got to be careful when you go up too high in resistance because then you can introduce noise to your inputs, and that can be a trap for young players too. That's not something I'm worried about in this particular. Oh, I clicked the positive. I was looking at my battery voltage and it was way too high. I was like, what the hell? Alright, so let's see how stable it is now. So, okay, now it's not turning off. Something's not right. Let's get a different piece of wire so I can have a better look around. Okay, VRF high is there. VRF low is there. Our pull-ups there. Oh, hold on. Oh yeah, because one's off. Maybe I need to change my threshold. Let's just go back to 3 volts. On the battery input. And let's turn this until the LED goes out. And come back until it goes on. Yeah, I don't see that working. No. It's trying to. So 1 meg does not seem to be able to do the trick. I'll go to 100k. You see what I mean about not doing math and just swapping values? I'm going to waste 5 minutes here and my maths is crap, so I'd have to get a calculator and do all these different calculations. When I can just do this, it saves me a lot of time. That seems to work. No. Maybe it's just the threshold. Yeah. All right. What the? fuck is going on here? All right, there we go. That's working perfectly. Yeah, I still wonder if that could work with 2 1 meg resistors. I'm just going to pause the video for a minute. Have a fiddle. You know what, I'll do it on camera. Sorry if I'm wasting your time, but I wanted to explain the mode of operation and show you guys a little bit of my working out. No, not enough current. There you go. You see the LED just go to change, but it doesn't want to. So, I have one question. Should I try and do this the original way I had it? No, I like that. That really has a more, yeah. Okay. Let's measure the current draw with it on. All right. Let's measure the current draw of this thing with it in the on state, and then measure it in the off state. What do we got? 250 milliamps. That should do the job. Oh, I got my freaking probes on back to front. Oh shit, it was in the 10 amp jack, okay. So, uh, 250, where's my milliamp scale? Oh. What? I haven't looked at this meter for so long, I've got can't remember what I'm looking at. Oh, okay, here it is. 250. 50. 25. Oh, 18 milliamps. I don't really want that much draw. Wait, I think one of my resistors might be popped in my meter. What's the burden voltage dropped from doing that? Ah, yeah, see my rail. No, that's where I had my rail. So burden voltage isn't coming into play until down there. Okay, what's going on here? I think my meter's got some bad contacts inside. I mean, according to that, that's 2.5 milliamps. But according to that, that's like 18 milliamps. I'm pretty sure the fuses are blown in my fluke at the moment. That's why it grabs the meter, that meter, just to be honest with you guys. I gotta go see what my mate wants. I haven't seen him for a while. I'm gonna leave the video here. I'll come back and get back on this, and then I'll just splice the two together. It'll just be two, but it'll be alright. You guys won't notice a difference because I'll be straight back. See you soon. Alright. One thing I just want to point out before I do go off and do this, I just had to let my mate in, and then it dawned on me that I was in the middle of explaining something. So I'll finish off what I was explaining, go hang out with my mate for a bit, come back, I'll have a fiddle around with those resistor values, and then we'll start making it up on this and fit it in this and put the second LED about there. Oh, sorry, there. Anyways, as I was explaining, the two comparators on this are just comparing the battery voltage with a high reference and a low reference. And as you saw in the first video, you can make the outputs light up two individual LEDs. So one will go on when the battery voltage is above 2.8, 2.9, and the other one will go off when it's above 3.2. So the LEDs are only going to be both on at the same time when it's in between that window. So if we take those two outputs and feed it into an AND gate, which is just made using a comparator that's, well, the positive input's got two 10K resistors on it, which is splitting the potential current from these two outputs to that one point there, right? And obviously when one's on, you've got half the current. When both are on, you've got all the current. So then if we go to a reference, right, with our negative pin, and we set the current there to equal the current here when both of them are on, this LED will only light up when both of them are on. So that forms an AND gate. Yeah, that's it. I am going to take out the two LM, what do you call them, 393s, and put a LM339 in there. I've got plenty of them to save using two chips. Try and get higher resistor values in there and see if I can make it work, and use at least two cheaper pots for the high ref and low ref. Maybe even all of them I might be able to just use single turn pots. But yeah, that's the refinement that's coming up. We don't need to add bypass capacitors to this circuit. It's not really subjected to noise or anything that's crazy that's going to make it do things. The 100 nanofarad disc ceramic on the inputs of the first comparator is already knocking off enough noise off the battery signal that by the time it even gets to the second input, I didn't need a capacitor there, and I certainly don't need one on the last one. The rail, I'm not worried about putting a bulk capacitor on the rail or decoupling capacitors across the VCC and ground pins, because it's basically right next to a battery, and a whole lot of capacitors anyway on the power rails. So it's for what it is, it's fine, you know. If these were op amps and there was music going through them, or some current sense circuit or CV circuit, whatever, yeah, it'd be decoupling all over the place. You wouldn't want the risk of noise getting into it. But for this, it's just got to turn an LED on and off at two different voltage levels, and as long as, in layman's terms, the noise is down at the level where it's not causing arbitrary firing of the LED and stuff like that, then it's not really a problem anyway. So, and it's nowhere near that, so I'm not worried about that at all. Yeah, all right. I'll be back soon. All right, so I was having a dumb moment. I've left the 200Ks there as the pull-ups because they're only on when the LED's on, or one of the LEDs is on. So it's not going to take too much current. And I've swapped the 10K resistors for 1 meg because I only need 1 meg to let enough current into the comparator. It takes fuck all current. So because the 200Ks and then going through to 10Ks, that's forming a path back, basically down one 100K and up the other, creating a current loop. So I've eliminated that. So I think that's as low as I'm going to get the current draw on it. I'll have another crack at trying to up the values on them, but other than that, I think I'm pretty well happy with it. I'll be back in a sec. Alright, I'm back again. So here's what I've done. I've got two 10 mega ohm resistors here on the inputs to this AND gate, and I have a couple of 1 meg resistors. I figured I'd just up the whole resistance of the voltage divider. And I just want to point out one more thing again. Yes, this could be done with one comparator, but it's going to take a resistor divider network between all of its inputs to essentially get it to form the AND function and be doing that job as a window comparator. Well, I guess window comparator is combining the two functions of the two comparing levels in the AND gate, but you get what I'm saying. That would take more current. So the reason I've gone about doing it like this is purely for current draw. So now my current draw should be substantially lower. I guess we can test that. Let's have a look and see what we have now. Bearing in mind this is with the LED on, there's going to be two different current draws to measure. See, that's a lot lower now. Oh, actually, it's not a lot lower, but it's a little bit lower. I mean, what have we got? 50, 25, 5, 10, 15, 20. We're down at 15 milliamps now. So I've just dropped another 3 milliamps. So I lost all the current on the voltage divider network now. So the only thing that's pulling the current now is basically that LED. Let's see what the current draw is when it's in the off state, because don't forget, this is only lit up when the battery is already flat anyway, to tell me it's flat. So the main current draw I'm concerned about is the quiescent current draw. So to do that, let's turn the LED off by putting our voltage above or below the threshold. And our current draw now is 10 milliamps. 10 milliamps. Let me just make sure this was zeroed. Yeah, no, it's zero. I just realized that's the ohm 0. I was talking about the needle being in the center. So yeah, that's bang on 10 milliamps. Oh, you guys can kind of see that. Cool. So, yeah, I wouldn't mind having a smaller current draw. I think that's just coming from mainly the comparators. I was led to believe that they would draw less current, especially under such... man. Yeah, you saw the needle drop. So that's the comparators that are taking all the current. Don't you try and go in the wrong hole. You know what? Freaking bump now. Oh, it's supposed to be off, yeah. Oh, goodness. Okay, you all saw that delay wasn't there before. You know that's just the loose breadboard. This circuit, this works. So I'm happy with that. Let's see again what the current draw is when it's off. Yeah. Yeah, I'm happy with that. I might have a look around and see if I have anything that will take less power. I'm just wondering if there's a way These guys do not go all the way down, do they? I'm just wondering how close I can pull up and pull down to rails with a 393. I honestly don't know. I know it's such a jelly bean part, but there are a lot of jelly bean parts and it's very hard to remember every single part's input offset voltages and this and that and current draw at different conditions. So I'm just going to have a quick look. LM393. One. Where are we? Wait, can these things swing all the way to the rail? With an appropriate pull-up resistor, of course. Maybe they can. So I just got to look at the data sheet for a sec. Well, it certainly seems like with an appropriate setup, like the pull-up resistor and input conditions, they can go quite far. The reason I'm wondering this is because I'm wondering if I could possibly run it off of a lower voltage. No, I'm not going to because I won't be able to set my references. You know what? I'm going to have to just put up with this. Unless I can find some parts that draw a lower current, I can't really think of a way to make these pull a lower current themselves. Let's have a look at references. Yeah, see, biasing the inputs doesn't seem to be even affecting the current draw. I didn't think it would. Yeah, no. So it looks like that's out of the question. That's just going to be the current draw for that. All right. I'm not going to even try and put single turn pots on a breadboard and try and fiddle with it and get it accurate like that. It's already hard enough to get it accurate with 10 to or 25, whatever turn pots they are. There's no way I'm going to be able to dial it in with single turns. So what I'm going to do now, I'm going to stop this. I'm going to get a single 339 and knock all this up on this little bit of strip board. I'll just cut like a, a small piece out of it. Probably like something about that. And put all this on there. And then we'll see what pots we can get away with, if we can get away with using cheaper pots. Because obviously the whole goal in this thing is to put as least money in it as possible. Yeah. Alright. That's it for now. I'll end this video here, and the next video will be us making it up on the circuit board. So that's all for now, guys. I hope everyone's got a better understanding of how this works and what's going on here. Like I said, sorry about the last video. It won't happen again. I've worked out what made my camera do that. So yeah. Alright guys, I'll see you in the next one. Please give me a like and a subscribe. I'm trying to get the channel to go, and I'm really not getting much likes or subscriptions. I'm getting more comments, if anything. So if you could all give me a hand, I'd really, really appreciate it. It's going to inspire me to make more content. I'm just being real with you guys. The more I see the channel grow, the more it inspires me to want to have more of a go at it. Because to be honest with you, I've actually thought about doing this for years, and I've just I thought it would not pick up, and I've already got to say I've been quite shocked to see how far it's grown already. So, but the only thing that I'm not seeing is much in the way of likes and, well, I guess subscriptions I am. But yeah, thanks everyone for their help, and please continue to help. All right, I'll see you in the next one, guys. Thank you.